Welcome to another episode of Beyond the Stars, the podcast that takes you on a journey through the vast universe of spacecraft technology and simulations. I'm your host, and today we're diving into an intriguing topic, the comprehensive simulation tool known as 42, which is designed for modeling spacecraft attitude and orbit dynamics. So let's get started with the basics. Have you ever wondered how spacecraft maintain their orientation and navigate the complex mechanics of flight? Well, the simulation called 42 is crafted specifically for that. It's a general-purpose tool that supports the design and validation of attitude control systems right from the concept phase all the way through to testing and integration. Now, what makes 42 particularly fascinating is its ability to model both multi-body dynamics and various orbital regimes. It handles everything from low Earth orbit to missions throughout our solar system. Imagine how many engineering challenges that entails. Whether it's a lone satellite or a collaboration among multiple spacecraft, this tool is equipped to simulate their behaviors under a multitude of conditions. Here's a fun analogy for you. Think of 42 like a cosmic chessboard where each piece represents a spacecraft. Just like in chess, where strategic movements determine success, 42 helps engineers plot the best paths for spacecraft, while also considering how they interact with each other. But 42 isn't just about attitude dynamics. It also supports scenarios like rendezvous and precision formation flying, which are crucial for missions that require multiple spacecraft to work together. How cool is it that engineers can visualize these interactions, almost like watching a dance in space? Let's chat about some specific features that stand out. For instance, 42 can simulate rigid and flexible bodies, and it accounts for varying gravitational influences, which is essential for planning missions to different celestial bodies. It even includes support for landers and rovers, making it a versatile asset in aerospace exploration. Now, transitioning to how to use 42, it's pretty user-friendly once you get the hang of it. For those installing on Windows, there's specific guidance within the documentation. Though, let's be honest, software installation can sometimes feel like solving a Rubik's Cube. The common pitfalls include ensuring you don't introduce any formatting errors in input files. It's often the small things, like smart quotes versus straight quotes, that trip people up. So, a little attention to detail is crucial here. And for you aspiring sim pilots out there, the beauty of 42 lies in its flexibility. You can change the input-output folder for a simulation run, allowing for great adaptability based on your project needs. The default should get you started well, but if you're diving deeper, you can customize to your heart's content. As we wrap up, I want you to reflect on the significant role simulation plays in aerospace engineering. It allows us to explore the complex interactions of various forces and bodies in space without risking a single rocket launch. The insights gained from simulations like 42 can lead to safer, more successful missions beyond our planet. Before we sign off, here's a thought-provoking question for our listeners. How do you envision the future of spacecraft collaboration as technology continues to evolve? Could we see fleets of spacecraft working in tandem across the solar system? Thanks for tuning in to Beyond the Stars. Be sure to join us next time as we explore more incredible advancements in space technology. Until then, keep looking up.